In this video, we will be discussing triangle congruence postulates. Now, before we start talking about how to prove that triangles are congruent, let's talk about some tools that we'll probably be using. All right, first tool we're going to use is medians. And a median is just a segment that connects the midpoint of a side to the vertex of the opposite angle. Okay, and so what it does is it cuts the side in half and connects to the opposite angle. An altitude is a segment that goes through a vertex, so a point of the triangle, and is perpendicular to the opposite side. So like this segment here is an altitude because it goes through this vertex and it's perpendicular to this side. Now the thing to know about altitudes is they will not always be on the side. Like in this case, we can see our altitude, it goes through this vertex, it's perpendicular to this side here, but it's not actually in the triangle. And that's okay. That's something that might happen with altitudes. So other tools that we haven't talked about before, perpendicular bisector. Okay, a perpendicular bisector is a line that goes through the midpoint of a side and is perpendicular to that side. So you just cut them in half, cut these in, or think about this. Bisector means it cuts it in half, and perpendicular means it's perpendicular. So it makes a right angle, and these two sides are these two segments, CE and AE, will be equal. And finally, an angle bisector is a line through the vertex that cuts the angle in half. So this is an angle bisector, AB, because it goes through the vertex A, and it takes my angle CAD and cuts it in half so that CAB and DAB are congruent. Now, those are just 4 new tools that we're using. We'll also be able to use any of the older tools that we've used previously in class, meaning our equality properties like transitive, symmetric, and reflexive, our properties of parallel lines like alternate interior and alternate exterior angles, properties of different types of triangles like isosceles triangles and equilateral triangles. We'll be able to use any of those things when we're trying to prove triangles are congruent. And the way that we're going to prove triangles are congruent is through using congruence postulates. Now, hopefully you remember that a postulate is simply a statement that we accept as true. We can't prove it. And there are 5 of them that we're going to discuss. Okay, this is a nice little chart that shows the 5 congruence postulates we'll be using in class. And I'm going to go through them one by one. So the first one we'll talk about is side, side, side congruence. We generally abbreviate that SSS. And what side, side, side says is that when all three sets of corresponding sides in triangles are congruent, then those 2 triangles are congruent. So if I've got ABC and DEF over here, and I look, well, side AB is congruent to side DE, side AC is congruent to side DF, and side BC is congruent to side EF. So I've got 3 sets of congruent sides. And if all 3 sides are congruent, then the triangles are congruent. So I can say, well, triangle ABC is congruent to triangle DEF. All right, so it's pretty simple. All 3 sides are congruent, then the triangles are congruent. Our second congruence postulate is side angle side, or SAS. What side angle side says is that when I've got 2 sets of corresponding sides that are congruent, like in this case I have MP is congruent to SR and QS is congruent to NP, and the angle between them is congruent, then the triangles are congruent. So I've got 2 sides, or 2 sets of sides that are congruent, and so is the angle that's between them. And that makes the triangles congruent. So if I can show 2 sides are congruent and the angle in between is congruent, then I can show that the triangles are congruent. Our third postulate is angle side angle. So we just did side angle side, now we're going to do angle side angle. The way angle side angle works is that if I have 2 sets of corresponding angles that are congruent and the side between them is congruent, then the triangles are congruent. Our fourth postulate is angle, angle, side. So in this one, once again, I have 2 sets of congruent angles, but instead of the side between them being congruent, it's one of the sides that is not between them that's congruent. And if that's the case, then still angle, angle, side still shows that these two triangles are congruent. So these two triangles are congruent because they've got two angles that are congruent and one of the sides that's not between them. And our fifth and final postulate that we'll talk about is specific to right triangles, and that is the hypotenuse leg, or HL congruence theorem. And it says that if I've got two right triangles, and I know that one of the legs and the hypotenuse is congruent between the two of them, then the triangles are congruent. All right, so this only works for right triangles. And it says if two triangles are right triangles, they have the same hypotenuse, and one of their sets of legs is congruent, then the triangles are congruent. So now that we have these postulates, we can use them to prove that triangles are congruent. And the way we're going to do this is we're going to look at an example, and we're going to say, okay, what is given to me? What do I know about these triangles? And what can I use? How can I use that to prove they're congruent? Which theorem works best given the information I know? So let's take a look at example 1. Example 1 says that we are given that C is the midpoint of AE, and C is also the midpoint of BD. Okay, and I've already put some markings on here. If C is the midpoint, then I know that AC is congruent to EC, and I know DC is congruent to BC. All right, so I have, well, I've got sides, two sets of corresponding sides that are congruent. That's not really good enough to prove. I need something else. So the question is, looking at this picture, what other information do I know? Well, I know from the way I look at this picture that C is included right here, and these two angles, well, those are vertical angles. And if they're vertical angles, then I know for a fact that they're congruent. So now, well, now I know I've got side, angle, side, side, angle, side. So I can use the side, angle, side congruence theorem to prove this. Okay, so just writing SAS up here, that's not good enough. Obviously, I need to write out a full proof. So let's do that. First thing I want to do, state my given. C is the midpoint of AE and BD. Then I say, okay, well, if that's true, then I know that AC is congruent to CE, and I know BC is congruent to DC just by the definition of midpoint. Okay, so now I've said my side and side. Now my angle, I know these two angles are congruent, angle ACB and angle ECD by vertical angles. And now I've shown, well, I've got two sets of sides that are congruent, and the angle between them is congruent. So I can say my triangles ABC and EDC are congruent because of the side angle side congruence theorem. And that's all there is to that one. We're going to look at a few more examples of this. Example 2 says, given AB is parallel to CD and AD is parallel to CB, I want to prove that my triangles ABD and CDB are congruent. Where can we go on this one? On this one, I haven't been given really any information about congruent sides or congruent angles directly. So what do I know here? Well, I know BD is congruent to itself, right? That's the reflexive property. BD is congruent to itself. I've not really been given any information that shows that these two sides are congruent or these two sides are congruent. I'm just told they're parallel. Well, what do I know about parallel lines and angles? If we think back, we've got alternate interior angles, we've got corresponding angles, we've got alternate exterior angles, and we've got consecutive interior angles. Well, don't we know that if AB is parallel to CD and they're cut by this transversal BD, then this angle right here is congruent to this angle right here by alternate interior angles. Similarly, if AD is parallel to BC, and once again they're cut by this transversal, then I know that this angle right here is congruent to this angle right here, also by alternate interior angles. Well, now what do I have? I've got two sets of corresponding congruent angles and a side between them, because this side's the same and it's in both triangles. So I can say by angle side angle that these two triangles are going to be congruent. Because I've got this angle, a side, and then the other angle, and this angle, the side, and the other angle. So there we go. I've got angle side angle. So let's do the full proof here. Given AB is parallel to CD and AD is parallel to CB, angle ABD is congruent to angle CDB by alternate interior angles. For the same reason, angle ADB is congruent to CBD. Then we can say, well, this side, BD, is congruent to itself, obviously, but the property we use for that's the reflexive property, because it's equal to itself. It's pretty self-explanatory. And then we can say, well, there we go. Our two triangles are congruent by angle side angle congruence theorem. So you can see that you got to use what you're given combined with your previous knowledge of triangles and parallel lines and all sorts of geometry concepts to come up with how to prove these. Let's look at our final example. It says, given triangle VRT is isosceles and VS is a median, we want to prove that VRS, this triangle VRS, is congruent to this triangle VTS. Well, let's see what we can go from here. Isosceles. Hopefully you know that in an isosceles triangle, two of the sides are congruent. And in that case, I could say, well, VT is congruent to VR because it's an isosceles triangle. Well, that's pretty easy. If VS is a median, we know that S is the midpoint of TR, which means that TS and RS are congruent. Because VS is a median, S is the midpoint. Now I've got two sides. Well, what else do I know? Similar to the last example, VRS and VTS both share the side VS, and that's congruent to itself. So now what do I have? Now I have 1, 2, 3 congruent sides, so I can use side, side, side congruence. And there we go. Let's do the proof. VRT is isosceles and VS is a median. Those are our two givens. VR is congruent to VT because the definition of isosceles triangles. RS is congruent to TS because the definition of median. And VS is congruent to itself because of the reflexive property. Therefore, these two triangles, VRS and VTS, are congruent by the side, side, side congruence theorem. And there you go. You've seen three examples on how to prove triangles are congruent. All you need to do, use your given information to figure out what you know about the triangles, figure out which congruence theorem is the best one to use to solve or to prove, and then just write out your proof.